In this lesson, we're going to use the percent proportion again with percent problems, but it's going to be a little bit trickier because now we're going to have some word problems, and we may not have those key words is and of to help us. If you look at workbook page 302, I've got a couple word problems for you from that page. The first one that I want to do with you is number 9. Another company's advertising budget is $7,200. So let's think about that for a second. Their advertising budget, that means the amount of money that they have set aside to advertise for their company, to advertise their business. So they've got $7,200 set aside for advertising. The company spent 30% of their budget on newspaper ads. That means 30% of the $7,200 was spent on newspaper ads. There's still 70% out there that they're using for other things, maybe TV ads or things in magazines, billboards, whatever. How much did the company spend on newspaper ads? If you were able to break this problem down, you would recognize that this problem is giving us the whole 7,200 and we're missing the part. 7,200 represents all of the money that they have for advertising, and 30% of that 7,200 was used for newspaper ads. And we want to know, well, how much money is that? How much is 30% of 7,200? So this would be how I would set up my percent proportion. I would have to cross multiply here. I have 100 times x, which of course is 100x. And then I have 7,200 times 30, which is going to give me 216,000. So I'll put that on the other side of my equal sign. And then the last step is to, of course, solve for x. And if I divide by 100, I am going to get, I can just cross off some zeros here, I'm going to get $2,160. So $2,160 was spent on newspaper ads. Okay, next one I want to do with you is number 11. If 3 gallons of antifreeze is mixed with 2 gallons of water, what percent of the mixture is antifreeze? Hopefully you're recognizing that we're missing the percent, the number over 100, which means we must have the part and we must have the whole. If we're talking about antifreeze, what part of the mixture is antifreeze? I'm thinking, let's see, if 3 gallons of antifreeze is mixed with 2 gallons of water, what percent of the mixture? So 3 gallons is the antifreeze. Do we know the whole? Don't just assume it's 2. A lot of people would say, oh, 2 is the other number, that must be the number that goes there. Think about what is the whole? What is the total amount of something? In this case, we're mixing antifreeze and water for our cars or whatever, I'm assuming for a car. That means that's a total of 5 gallons going into the engine. 3 gallons of antifreeze with 2 gallons of water. That's 5 gallons total in our mixture. So our whole is 5. We had to combine the antifreeze and the water. Now I'm ready to solve it. I can cross multiply. And I have 5 times x equals 300. And all I have to do is solve for x. And I'm going to get 60. So 60% of the mixture is antifreeze, which means the percent that's water must be 40%. How can we prove it? Let's do the work. Let's see, I'm going to make some space here. Maybe I'll use a different color. Red works. Okay, so what percent of the mixture is water? So again, we're missing the percent. We've got 2 gallons of water out of the total 5 gallons. So if you cross multiply, you have 5 times x equals 200. And when you solve for x, you're going to get 40. There's your percent. So if 60% is antifreeze, then 40% must be the water, and that gives you the total 100% mixture. Okay, one more that I want to do with you. If a pharmacist needs to mix 800 milliliters of antibiotic with water so that the mixture is 40% antibiotic, then how much water does the pharmacist need? Or need to add? Let's see, we've got our percent, 40% out of 100, and they need to mix 800 milliliters of antibiotic with the water, and we want the mixture to be 40% antibiotic. So 40% represents the part over here, the percent part. Well, guess what? 800 is going to represent the part over here. That's the antibiotic part. That's the 40%. 40% same as 800 milliliters. And we're missing the whole. So now I can go ahead and start cross multiplying and solve it. I have 40 times x, and I have 80,000 when I do 100 times 800. And then, of course, solve for x. 80,000 divided by 40 is going to be 2,000. Now, be careful with this one. Is 2,000 the amount of water that the pharmacist needs to add? Is the water supposed to be the whole amount of the mixture? No. The mixture is antibiotic and water. And we know 40% of it is antibiotic, meaning 60% of it must be the water. What I might do is I might take the 2,000, which is supposed to represent the whole amount of mixture, and I'm going to take out the 800 milliliters that represents the antibiotic part, which means 1,200 would be the amount of water. 1,200 milliliters is the amount of water that the pharmacist would need to add, because the 1,200 milliliters of water plus the 800 milliliters of antibiotic would give me the total 2,000, the whole amount. Another way you could look at it is, instead of solving it using the 40%, maybe you can think, okay, if it's 40% antibiotic, then it must be 60% water. So maybe I'll put the 60 over 100, because 60 plus 40 gives you a total 100. 60% must be the water. And then, let's see. Well, I guess you don't really need to do it this way. You know what? Let's scratch that. Okay, so here are the takeaways. There's not too much here, but basically you can still use the percent problem, to solve you can use the percent proportion to solve percent word problems, but just keep in mind that the part and the whole may be a little more difficult to identify. So you have to think to yourself, did they give me the whole amount of something? Or did they give me part of an amount? You have to be able to interpret the word problem and break it down and figure out what information they're giving you and where it fits in your percent proportion.